In this example, we're going to take a look at a couple of possible matrix multiplications. So first thing we'll do is define two matrices. We'll start by defining the matrix A as the 3 by 3 matrix, first row, 2, -1, 5, second row, 4, 3, -6, third row, 5, 0, 4. B will be a 3 by 2 matrix, first row, 1, 3, second row, 2, 4, third row, -2, 5. So the first thing we're going to do is check to see if it's possible to calculate AB. So multiplying A times B, first thing we'll do is recopy these two matrices so that they are properly juxtaposed to imply multiplication. There's our matrix A, and here's our matrix B. Now what I like to do to make sure that matrix multiplication is actually defined is I copy down the size of the two matrices, which are 3 by 3 and 3 by 2. Now with this in mind, we need to make sure that the number of columns of the left matrix matches the number of rows of the second matrix. If that is the case, then your matrix multiplication will be valid. The size of the result is going to be the number of rows of the left matrix and the number of columns of the right matrix. So each of the entries of this 3 by 2 matrix will have a total of 3 products being added together. The idea is we're going to go left to right across the rows of A and top to bottom across or down the columns of B, and we'll be multiplying corresponding entries together. So for the 1, 1 entry of our product, we'll be multiplying the first row of A times the first column of B and multiplying the corresponding entries together. So 2 times 1 plus -1 times 2 plus 5 times -2. For the 1, 2 entry of the product, we'll select the first row of A and the second column of B, and once again multiply the corresponding entries together. That'll be 2 times 1 plus, that should be 2 times 3. Went back to the first column. So 2 times 3, -1 times 4, and 5 times 5. There we go. I used to call this the Facebook technique because it involves a lot of poking. I don't think people poke anymore though. For the 2, 1 entry, we'll do the second row of A, the first column of B, 4 times 1, 3 times 2, and -6 times -2. So 4 times 1, 3 times 2, and -6 times -2. For the 2, 2 entry of the product, we'll do second row of A, second column of B. So 4 times 3, 3 times 4, -6 times 5. 4 times 3, 3 times 4, and -6 times 5. Nice. For the 3, 1 entry, we'll do third row of A, first column of B, multiply the corresponding entries together. So 5 times 1, 0 times 2, and 4 times -2. And finally, for the 3, 2 entry, we'll do the third row of A with the second column of B. So we'll start with 5 times 3 plus 0 times 4 plus 4 times 5. Once you get to this point, it is simply arithmetic to simplify each of these entries, and we'll see what we get for a final result. So for the 1, 1 entry, I'm seeing 2 minus 2 minus 10. That'll be -10. For the 1, 2 entry, I'm seeing 6 minus 4 plus 25. That'll be 27. For the 2, 1 entry, 4 plus 6, that's 10, plus 12, that'll be 22. Bye, BB. For the 2, 2 entry, we'll see 12 plus 12, which is 24, minus 30, that'll be -6. For the 3, 1 entry, 5 plus 0 minus 8, that'll be -3. And then finally we have 15 plus 0 plus 20 for a final result of 35. So AB is a valid matrix product, and this is the result once we perform that product. Now BA is going to be considerably shorter. Reason being, if I copy down matrix B, which is 1, 3, 2, 4, -2, 5, and copy down the matrix A, which is 2, -1, 5, 4, 3, -6, 5, 0, 4. B is a 3 by 2 matrix. A is a 3 by 3 matrix. And if we do the same test as what we did for the last one, these two numbers have to be equal to one another in order for the matrix multiplication to be defined. That is not the case. As such, we can say BA is not defined. Now, if we were to use a calculator to do something like this, I believe what the error that you would get here is dimension mismatch, just meaning that these two numbers are not equal to one another, therefore the multiplication is not defined.